This video covers the retest review 14 for quadratic functions part 1. This is to be taken care of by Friday, March 9th. So problem 1 asks us to answer the following based on the graph. First, it asks for the y-intercept and what does it represent. I'm just assuming that these are all in units of 1 unless they tell me differently. So my y-intercept would be 1, 2, 3, 4, 5, 6, 7, 8. And it would represent my starting height, because when time is 0, that's where you start. And then my x-intercept would be at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10, 0. And this would represent, I'm guessing something's being thrown here. So when the item hits the ground. And then C, identify the vertex. The vertex is your highest or lowest point. So I'm going to switch colors. So in this case, it would be highest. So that would be the point 1, 2, 3. And then this was 8, 9, 10. So 3, 10. And that would be the highest point for this graph. So problem 2 tells you the area of a rectangle is represented by w squared plus 4w equals 60, where w is the width. Find the width. So I'm going to do as much as I can in the calculator. Before I can plug into the calculator, I need an equals 0. No matter what you do, you need an equals 0. So w squared plus 4w minus 60 equals 0. Now I'm going to open up my calculator. It takes a hot minute, so while I'm doing that, I'm going to write out my steps. The first thing I'm going to do is put this in y equals. So I have x squared plus 4x minus 60. And then I'm going to hit graph. If you want to, you can zoom out, zoom 3. Right now we're at zoom 6, which is your basic. Now I know that I'm trying to find my solutions in the calculator, which is my x-intercept. So I do second trace 2 and follow those steps. Now, your width can only be a positive number. So I have something maybe a negative 10 and a positive 6. I'm just guessing. I'm going to double check because the retest is all open-ended. So if it's 6.1, I would get points off. So I only need for real world, excuse me, real world situations, I only need the positive 0. So I can see my y is at negative 60. I'm going to the right because I want it to pop up over here. So I move to the one I want. It says left bound. So I move to the left and click enter. Go back to the one I want. Move to the right. Enter, enter. And so my width is 6. And those steps for finding the x-intercept can be found on your pink paper. If you need a new one, it is listed on 14.5 is where the Unit 14 calculator steps can be found on our website. Problem 3 asks me to find the vertex of this quadratic equation. So I am going to put this in y equals and follow my calculator steps again. So negative 4x squared plus 12x minus 5. I can see, I have to remember for the vertex, I have to see if it's a max or a min. So because this is a min, so my first step was put in y equals. My second step, second trace. Because this is a max, I will do 4. So second trace 4. I move to the one I want. It's about there. Move to the left. Enter. Move to the one I want. Move to the right. Enter, enter. And my vertex is 1.5, comma 4. Problem 4, they asked me to find the solutions to this quadratic equation. So my steps are going to be put into y equals, graph. Solutions mean x-intercepts. So graph and find your x-intercepts. So in y equals, I need x squared minus 3x minus 15. So I remind myself these are my x-intercepts. In order to find my x-intercepts, I do second trace 2, because 0 is another word for x-intercept. So second trace 2, move to what I want. That's about what I want. Move to the left, enter, move to what I want, move to the right, enter, enter. So very ugly, but one of my x-intercepts is 5.65. Did it tell us what to round to? No, it did not. So my other second trace 2, again, I found the one on the right, so I need to use the left arrow until I can get to the left. There I am. Oh man. So I go to what I want. It's about there. Slide to the left, enter, move to what I want, slide to the right, enter, enter. And my other 0 is negative 2.65. Problem 5, we don't need the calculator because they gave us a graph, so they ask me for the y-intercepts and the x-intercepts. These are going to be two different things, so I will color code them so we can see them better. Y-intercept is where it crosses the y-axis. This is my y-axis. It crosses here at 2. So that is the point 0, 2. Remember, the word intercept is really fancy for the other number is 0. My x-intercept is where it crosses the x-axis. We cross, that looks like about 1/2 and negative 3/2. So 1/2 and negative 3/2. Okay, and again, they wanted them as ordered pairs, which is why I did them with parentheses rather than just listing them out. Problem 6 asks us to take this graph and find the axis of symmetry. So my axis of symmetry is based on my vertex. We don't have the A and B values, so we can't use the formula. So we're just going to have to estimate. Now halfway between, that's about halfway between my 1/2 and my 3.5, so halfway between is negative 1.5. And my axis of symmetry is always listed as an equation. X equals the x from your vertex, which we don't have, so x equals the in between my solutions. Problem 7 asks for the roots of the quadratic function. The roots are where it crosses the x-axis, so it crosses at 1 and negative 3. This does not ask me to write it as an ordered pair, so I could probably just get away with writing them as numbers. 8 asked me to find the zeros. Because they give me an equation, I'm going to go back to using my calculator. So in y equals, I plug this in exactly like I see it. Negative 4x plus 8, graph. My zeros, so I put this in y equals, graph, and find the x-intercepts by doing second trace 2. So second trace 2, I go to what I want. I want the x-intercept. Slide to the left, enter. Go back to what I want. Slide to the right, enter, enter. So my 0 is at 2. Notice because this has an exponent of 1, invisible 1, it will only have 1 0. This one is asking us to use this graph to talk about a baseball that is being thrown from the top of the building. So basically we have a building here that is not drawn. Someone's standing here, and they throw the baseball really, really, really high. Okay, so the path of the baseball, it reached its maximum height at 9 seconds. So the maximum is our vertex, which is 125, so that is not 9. At 0 seconds, the ball was 125 meters off the ground. So when time is 0, 125, no, it's at like 45. The baseball was in flight for 4 seconds. Well, it didn't hit the ground over here until 9 seconds, so it's not that one. So the maximum height was 125 meters. So the maximum Y value, yeah, that's pretty accurate. At what time is the baseball at a height of 80 meters? So 80 meters is here. It hits at a time of 1 and a time of 7. So 1 and 7. When did the baseball hit the ground? What is the time when the height is 0? So my height is 0 here, which would be 9 seconds. And how much time elapsed while the baseball is 70 meters or more above the ground? So the ball hits 70 meters at about what, 0.6 seconds? And it's there from 0.6 seconds, it's 70, 70, above 70, above 70, above 70, all the way until like 7.2-ish. Of course, I'm just estimating these. So it's above 70 from 0.6 seconds to 7.2. So let's find that total, 7.2 minus 0.6. So about 6.6. C is the closest to that. So for that, you just find the 2 points where it hits and then subtract them. And that's all.